Hello everyone, this is question 8 on the practice exam, and you've been given a tripeptide in the notes, and here I've greatly simplified it, showing you instead of those big groups coming down off of it, A, B, and C. And really when you do approach a problem like this or any polymer like that, remember that the backbone is the most important part of it, and all that other stuff is just extraneous and hopefully it doesn't confuse you, okay? We can call this A, B, and C at the moment because we don't necessarily care what's going on in those cases for the rest of this question. And it makes it a little easier to draw on this little board. So the first question in this case, it says, circle the peptide bond and indicate the functional group involved. So with peptides, hopefully you've seen from the notes, these are made up of amino acids. And the amino acid has an amine end and an acid end, or carboxylic acid. When they come together, the condensation release water and you make an amide or an end. So here, there's one of them, there's the other. Okay, the rest of it is just a CH putting the two together. So that word is amide. Now, the second part of this question wants you to break the tripeptide down and draw the 3 amino acids that are used to make it. So looking at this backbone, you want to go along and find your amides. Because remember, that's what came together to make the peptide bond. So you want to break those apart to put it back into its separate pieces. So along here is your amide. You're going to break that guy in half. Remember, this came together with carboxylic acid and an amine kicking water out. Here's the other one. Break that down. So here's our 3 chunks, A, B, and C. So if you want to write those out, first part is pretty easy. So NH2, CH, A, and we're at this stage right here. It's what else is on there? Remember, this has to be a carboxylic acid. So you're missing an OH on there. So I went into putting this together was condensation, so removing water. So going the other way, you're putting water back in there. Want to think about that, okay? So you would have HOH going back in. The OH is going to go with the C, the H goes with the N. So there's one. Then we have the second one. So that means we're adding an H to this side. Remember, it has to be an amine. So it's going to be H2N, CH, there's B. And then again, you have that C double bond O. The other side is a carboxylic acid. And then again, over here, you have an amine, CH. C is our group. And that end is already drawn for us. So there are our 3 peptides. Now, part 3 says that you're going to make a protein from these 3 peptides. So putting them together, and that's going to make up the repeating unit of our protein. So you want to write a balanced chemical equation involving these 3 to show how they would create a peptide, a protein with that as the repeating unit. So I'm going to use what I've already drawn here just for space. And in this case here, you'd be mixing these guys together, and they are all monomers. You happen to have 3 monomers. Those guys, then my arrow kind of comes around. Okay, I'm going to draw it like that. You're now putting them back together, which is exactly what you had up here. Okay, so I'm going to write out the ends, just kicking that guy out for now. So NH. Write this out. Just like above now, you're kicking out a water, right? You get rid of a water, so you're going to make a new CN bond. That's our amide functionality. Okay, B, C double bond O. Again, you're kicking out a water. And H. Okay. So I've written it out, just adding those 3 monomers together. And a few things have happened. First of all, you've kicked out 2 waters in this case, right? But this is not really showing us the repeat unit. It is, but we have to show it that it's a repeat unit. Here it just looks like a tripeptide. So you have to show that this guy keeps going and going. This keeps repeating. You're taking that chunk right there. Remember, you have to have a nitrogen bound to a carbon, right? You're taking that chunk and you're repeating it and repeating it. So in order to show that, you're going to cut off this H, that came on when you're making it, right? And you're going to cut off that OH on this side here. There's that water that would be lost. And you're going to put a little N there saying that this just keeps continuing. To balance everything, that means that you had to add N of that guy, N of this guy, N of that guy, okay? And what else is in there is the water, right? And for every one of these here, think about how many waters we generated. 1, 2, 3. Okay? So you're going to have 3N water that is also formed. Now, the last part of this question is all about molecular weights and just getting masses. So let me go to the question. It says if you have 5.25 kilos of cysteine, okay, and maybe I'll erase up here. What's that? We'll leave the rest in there though. So you're going to have a mass of cysteine, and you want to know how much mass of the polymer you can make, or the protein in the end. So I'm just going to go through how you would get to there, but from mass of cysteine, you can get your moles of cysteine. So you're looking at the cysteine one, which I can't remember, I think it's B. The one at the thiol in the picture, yeah, so B. You need your molecular weight, this guy. So you're going to go to moles, and then you're going to say, well, for every 1 cysteine, I have 1 show up in the repeating unit. So that means that my moles of cysteine is equal to my moles of my repeat unit. And if you know your moles of your repeat unit, you can then go to mass of the repeat unit, which is what you want to get. You need to know your molecular weight of the repeat unit, which is from there to there. You're going to use that right there. And so your final answer you should be getting is 14.7 kilograms.